So in this platform, we are going to have a revision for the June 2024 exam, which is important for us to consider as we are preparing for the exams which are ahead of time. It is actually important for you to consider other revisions or other provinces as you are revising, so that as an individual, you can see the similar questions. How do they ask these questions as you are preparing? So you're not going to waste our time quickly going through the questions that we are given. This is a paper one that we are going to consider. So as part of your instructions, you must consider that you go through all the instructions and information that you are given. So especially here on number 5, that if necessary, round off your answers to 2 decimal places unless stated otherwise. So we are going to see that in our answering of the questions that we are given, so that we can see where it is necessary, and wherever it is stated something else, use what is stated there unless stated otherwise. So that is what we have. Make sure that you read all the instructions. So on the first part, which is our section A, the first question that we are given here, it was to answer questions 1.1 up to 1.5 by choosing the correct answer, right? Then circle the letter next to the correct answer that you're given. So as we are given this part, it's just a multiple choice, guys, where the answers are already available. We just need to figure out which one is the exact answer that we are given. All right, so the first one that we have, which is on 1.1, which of the options below contains rational numbers only? So it is not just you see a rational number, then you say, okay, this is the answer. But the question is here, we are supposed to have rational numbers only. No other type of number there that you're supposed to be working with. Only rational numbers. So remember, rational numbers, these are the ones that we can express as fractions in the form of A over B. Remember that? Where A and B are integers and B cannot be equal to 0. B cannot be equal to 0. So we just need this condition. Can we have the given numbers, the given decimals, as a fraction of A over B? If that is possible, then it is a rational number. All right. So looking into A, we can see that 1 over 4 is a rational number. As we can see, it's a fraction. A over B, 1 is an integer, 4 is an integer. Then we have got the square root of 4 over 0. Guys, just to have a number divided by 0 like this, 4 over 0. We do understand that mathematically, this does not exist. All right? It is not part of real numbers. That's a non-real. So automatically, this is out. Yes, this one is a rational number, but we can see that this one is not. So meaning to say, A cannot be our answer. We move on to B. If we are to check these decimal that we are seeing here, they are not recurring decimals, like where we consider those decimals that have got repeating values or a repeating value. It is not that type. Recurring decimals, remember 0, 1, 1, 1, 1, like this. If it is like this, we know that it can be written as A over B. So these two are not. Yes, square root of 89, if we are to simplify, of which we cannot even simplify the square root of 89. Everything, yes, not. So that was totally out. Let's see on this part C, what we have. The square root of minus 100 on its own, guys, it is telling us we cannot simplify the square root of a negative. This is total out. Yes, this one can be expressed as a over b. Remember 0.25 is same as 1 over 4, same as this one. So it is fine, and also this one, but this is not. So it makes the whole of this to be wrong. So automatically our answer was going to be D, but let's see if truly our answer is D. All right, on D, we are given the first one is -8. Remember, integers are all rational numbers. Integers, -8. Because -8 can be written as -8 over 1. That's a fraction. So it makes it to be a rational number. We talk of the square root of minus the square root of 144. So take note, the minus is not inside the square root here, like what we had here on the -100, this one. The minus was inside the square root. That one you cannot simplify totally. But in this case, the minus is outside of the square root. It simply means minus, which means there is a number there, minus what? Just like -1, times the square root of 144, which we know. If you do not know that, you can use your calculator. Remember, you're told to use the calculator. So you can simplify the square root of 144, which is 12. So multiplying this was going to give us a -12. Guys, -12 and -8, are they different? No, just one and the same simplification. If -8 is a rational number, automatically -12 is a rational number because it can be written as -12 over 1. Same as what we had here, -8 over 1. So this is a rational number. We have a mixed fraction, 5 and 7 over 8. This one, guys, without wasting much time, it is also a rational number. At the end, remember, a mixed fraction can be converted to be an improper fraction. We have got something like 7 over 3, 8 over 5. These are improper fractions, but still they are what? Fractions, a over b. So it means this is also a rational number. So the correct answer was going to be D, where we have got all of the given numbers as what? As rational numbers. The case here was therefore only rational numbers. All right, so that is what we are given. We just need to play around questions. Make sure that you understand the simplification to answer the question that you are given. To simplify this 100p to the exponent of a, then to the exponent of b, what are we going to do? So in this case, if we were to properly simplify this, this is 100 p to the exponent of a being raised to the exponent of b. You're going to raise 100 to the exponent of b. You also raise p to the exponent of a to the exponent of b. So it's going to be like this, 100 to the exponent of b, this one. You do the same thing. You separated this 100, but there is a p raised to the exponent of a, this one. So you're going to take this part also and raise it to the exponent of b. So it was going to be like this, p to the exponent of a to the exponent of b. So as we can see, we applied the exponents here. We separated exponent of b on what? On 100. Does that mean 100 was not having an exponent? No. 100 is having an exponent. It's a 1. So if you actually do not understand that, you can have the 1 here. 100 to the exponent of a 1 like this, then to the exponent of b. Still, you see the same thing. So at the end, you're going to multiply these exponents. Remember your laws, x to the exponent of a to the exponent of b, you simply multiply the exponents. So in this case, you're going to multiply this exponent and this exponent. So it was going to be 100 to the exponent of 1 times b, which is b, Then we've got p to the exponent. We multiply a and b, which is ab. So that was the simplification. But here they are not asking us about this simplification. They're asking us of what is happening. Are we adding the exponents? Are we subtracting? Are we multiplying? Are we dividing? So that is the condition. Everything is centered on the exponents here. Look at the answers properly. Everything is centered on the exponents. So meaning to say, we are supposed to go back to the simplification where the exponents were involved. When this part, we had exponents. On this part, we had exponents. How did we simplify? We multiplied 1 times b, that was multiplying exponents. A times b, obtaining ab, that was multiplying exponents. So meaning to say, the correct answer is going to be C. Multiply the exponents. Multiply them. That is what we're supposed to have. Then 1.3, it's a direct question, guys. Without wasting time, we can simply see that these are like terms. And we do understand, guys, our rule when we are dealing with like terms. This is x, this is also x, this is also x. So when we are adding, subtracting, guys, you just simplify the coefficients of x. There is what here? There is a 4 over 5. What is the coefficient of x on what is following? That one is a minus. So you take it with a minus. Here we have got what? Minus 1 over 15. The question is simply asking you to simplify this. But remember, your answer must have x at the end. You must have x. So guys, this is section A where you have got answers already. Use your calculator. These are fractions, so I can simply use my calculator. 4 over 5. All right, move aside. Then we subtract 1 over 3. Move aside, we subtract 1 over 15. So that was going to give us 2 over 5. All right. Are we having 2 over 5? We have a part 2 over 5. Remember, our answer is supposed to carry x. So meaning to say the correct answer was 2 over 5x, which is on B. That is what we have. These are just like terms. You simplify as usual. As usual. So looking into this question, guys, we can have any other letter there presented. You're supposed to understand that you're simply working with what? Like terms there. Same question with 1.4. Subtract. What are we supposed to subtract? 3a over 9 from. Take note of this word, from. From where? From a over 9. Meaning to say, from is the one that is subtracting a over 9. This one is the one that is subtract this. Subtract, that is, have a minus from this one, from. So you start with from. A over 9 minus, what are we subtracting? 3a over 9. So these are just algebraic expressions where we are referring to our like terms. Just like the previous case, here we talked of the like terms. So what is the difference now? There's no difference. Same thing. Same thing. So we can simply subtract. This is a, which is same as 1. If the coefficient is not shown, it means there is a 1. So this is same as 1a. So what are we simply doing here? We are simply subtracting 1 over 9 minus 3 over 9. What are we going to get? That is the case. But knowing that our answer must have a at the end. So you're going to see 1, since the denominators here are the same, you simply subtract 1 minus 3. So what is 1 minus 3? That is minus 2. So you've got minus 2 over 9. So in our case, it will be minus 2a over 9. Remember that there was a there, just like what we had in our previous case where we're dealing with x. So that is it. Minus 2 over 9a, which is on what? On b. So the best answer that we're going to have there was going to be on b. And if we are to consider also, guys, our calculators are there, we can simply subtract 1 over 9 straight on our calculators minus 3 over 9. You get the answer there. So as we can see, this is minus 2 over 9. So remember, it's minus 2 over 9, but you're having what? You're having a. So the a can be written on the numerator, or you can have it aside. It's up to you. You can have it aside or on the numerator, but not to write it as minus 2 over 9a. This is totally wrong. A cannot be of the denominator, this one. It can be written in the numerator or aside like this. So these are the typical questions actually that you might have in your revisions. So we just need to work with more of these. 1.5 we are given, which equation below shows the correct use of a commutative property. So remember your commutative, you got the product of A and B, which is same as BA, then addition of A and B, where we can even start with the B, it does not affect. So guys, if you are to check, this is exactly what you're given on number A, this one for addition. We're given a commutative property under addition. So already the answer was there. All right, so moving on to section B, which is part of our question 2 now. Consider the following. 2.1, given the number 63 with prime factors, 252, also its prime factors, 378, also with its prime factors. We were given on 2.1 to write down the HCF of 63 and 378. The highest common factor. Remember, we talked about this separately as a class, that it must be common. That's the first thing. And we can have our factors written as prime factors like this. We talked about this also. So for the highest common factor, you're supposed to consider where it is common and having the least power or the smallest power. That is the major part. And having the smallest power. For prime factors which are written in index form like this. All right. So we consider where we have got our 63 and also 378. First, do we have anything common? Is 2 common? We have a 2 here, but we do not have a 2 here. So 2 is totally out because it must be common. We move on to 3. There is a 3 on 378. There's also a 3 on 63. So when it is common, we move on to the next thing and having what? The smallest power. So which one has the smallest power between these 3? There is 3 to the exponent of 2 compared to 3 to the exponent of 3. So meaning to say we're going to take 3 to the exponent of 2. It's common. 3 is common between these two numbers and has the smallest power here. We move on to another one. 7 is there on 63. 7 is also there on 378. And having the same power because it's just a 7 as it is. So remember, we said the number must be common and having the smallest power. But in the case of a 7, we cannot say this is the one that has the smallest power or this is the one. We just take a 7 as it is, because as it appears there, it is the same part of it. It is the same thing. So we cannot have a comparison to say which one has the smallest power there. We just take that 7 as it is. So that was going to be our HCF. So simplifying, guys, 3 squared times 7, as you can see, this is the one here, 3 squared times 7, which was taken from which number? From 63. If we simplify this, we're going to get a 63. So that was the condition. You can even see it, guys, straightforward from the table. All right, write down the LCM of 252 and 378. 252 and 378. The LCM, it has nothing about being common. The number must just exist, must be there, must be available, must be visible, and having the highest power. In a case that that number is found throughout or common. But it is nothing about being common there. It is just a number appearing. So between 252 and 378, we can see that a 2 is appearing and being common, just that it is appearing both. If it was not appearing both, it was not going to affect our answer. We're going to take as it is. It is only the HCF which is affected because the number has to be common. The LCM has nothing to do with the numbers being common. We just take every number that you can see. As long you can see that number, it has to be on your answer. Every number. So 2 is there, but which one has got the highest power now? 2 to the power of 2. We move on to 3. There's a 3, there's a 3. Which one has the highest power? 3 to the power of 3. There's a 7, there's a 7. Which one has the highest power? Same power. We are talking about the same number. So this is what you're going to have, and you can even simplify this on your calculator, guys. Straightforward, you're going to get 756. So your calculators are there, guys. 2 to the exponent of 2 times 3 to the exponent of 3, then times 7. All right, so you're going to have 756. If you put back your calculator to the normal mode, you'll see that 756. So questions can be altered, changed in terms of the numbers, but same simplification or same way of answering the question. That is what is important. How are you going to answer it? You see such type of a question in the future. So that was our question 2.1. Then 2.2, we are given 2 guys here that each bought a pair of jeans from 2 different shops. So they went for shopping, then they bought a pair of jeans. So if you are to consider here, they're saying the selling price of the pair of jeans was 599.99 in both shops. It was the same selling price. But as they entered these shops, we are now told that both shops offered a discount on the selling price as given below. So it's very true. They enter different shops, but as they enter those different shops, the selling price was the same. But what follows after was different, which is the offer, the discount now. It was the one that was different. So let's see about these two discounts. The first one, it was for the guy called Vusi. Vusi bought his for 20% less than selling price. That was for Vusi. He had to pay 20% less. Remember, less minus 20% of that, then you minus. What about Temba? Temba only paid. This is what he only paid. 3/4 of the selling price. 3/4. Okay? But we cannot tell now. Of which, if you are into a mathematical view of, if you understand your mathematical, you can even see like the percentages here, because this is given as a percentage and this is given as a fraction. So if you wanted to know who paid this or who paid, you're going to work with the percentage. You just have 3/4 as a percentage. How do you convert to a percentage? 3/4 times what? 100%. Because as it is, it was at 100%. Then this person is paying 3/4 of that. So what is 3/4 of 100%? You're going to get 75%. Meaning to say, he paid 75% out of what? Out of the 100%. So where is the rest? 100 minus 75, which will be something like 25%. So meaning to say, according to the Temba here, it is the same as they were saying. It is the same as they were saying. There is a 25% less, which is there is a 25% discount, but they did not mention it that way. He paid 3/4 of that. So the difference is the what can we say? How to present yourself, how the statement was presented here, but it means the same. But anyways, if you do not understand that, it's not a problem. You understand each other because you're not answering the question. I'm just elaborating what is there. So the question was, who paid less for his pair of jeans? Support your answer by showing all calculations. If I want, I can use percentage, guys. I can say, okay, Vusi here bought this for 20% less. But in terms of percentages, Temba here paid 25% less. So it means the more discount, thus the lesser you pay. If the discount is big, you see a bigger percentage, it means you're going to pay less, isn't it, guys? That is it. You're going to pay less. So to pay less, more discount. That's it. So by using percentage discount given, we can use a comparison. Vusi 20% less. But Temba, it's what? According to percentage, is 25% less. So therefore, Temba paid less. Therefore, Temba paid less. Remember, we want who paid less according to their percentages of discount. But let's say I don't understand this because we are not all on the same page, guys. What were you going to do? You calculate the amount now to say, okay, when Temba was given that 3/4, or when Vusi was given that 20% less, what is it that he paid at the end? He paid what? So let's start with the Vusi. For Vusi, there is a 20% less, which means we need the 20%, 20 over 100 of the selling price. selling price, which is 599.99. So that was going to give us the 20%, guys, is the discount, 20% less. So 20% of this will less. Remember, 20% means 20 over 100 times what you're going to remove there. So it's 20 over 100 times 599.99, like this. So that was going to give us 100 and 100 and okay, this is to 3 decimal places. Remember, dealing with money. So let me go and fix my calculator to 2 decimal places. So it was going to give us 120,00. All right, so you're going to obtain 120,00 like this as a discount. This is our discount. A discount means remove that, subtract it. Instead of paying a certain amount, you're going to pay this less. So you remove it. So at the end, Vusi had to pay 599.99 minus 120,00. So that is what he was going to pay at the end. We are supposed to subtract the difference, the discount. This is our discount. So what do? You subtract. So in terms of money, guys, where you add, think of that VAT, value added tax, and added the tax. There is a discount. Less this, subtract that part. All right. So that is what we're going to have, guys. So anyways, let's subtract 599.99 minus 120,00 like that. So it was going to give us 479.99. So this is what you're going to have for what? For Vusi. This is what he paid at the end after being given a 20% discount. But we said Temba was given a 25% discount when we had it calculated as a percentage. But we don't want to use that. We want to use what is given straight here. They say Temba only paid 3/4 of the sale. He only paid that. That is what he only paid. Temba only paid. So meaning to say, what is that he paid? 3/4 of the selling price. Remember your selling price. 3/4 of that. 599.99. So this is what Temba paid. 3/4 of this amount. So if they said 2/4, whatever that is, you multiply that as it is. There is 3/4. So it's 3/4 of that amount. So this is 3/4 of this amount that you're given of 599.9. So this is what Temba had to pay at the end, 449.99. So Temba paid this at the end. And Vusi, this is what you're having. So the question is, who paid less? We can see it by comparing now. So instead of using those percentages this is another way. So here we can say, or that's another way to calculate their exact values. We could have seen that, guys, by just using the amounts. So we can see that Temba on this side is the one that has got a lesser value, 449 compared to 479. 449 is less. So therefore, Temba paid less. That was the question there. Who paid less? So guys, I said we could have direct answer this question here by when we saw this person to say, okay, this one has 20%. This one has got 25% discount. The more discount, it means less amount paid. That is what it means. The more percentage of a discount that you see, the lesser you pay for that particular item. All right, so that was it. Without wasting time, let's see another part 2.3 where we are given a young couple left the house and drove toward the north at an average speed of 80 kilometers per hour. So what we are given on this information is the information of the young couple, which had a speed as they were driving. The speed was given as 80 kilometers per hour. Their uncle left the same house sometime later. After some time, he left, driving in the same direction at an average speed of 88 kilometers per hour. That is their uncle now. His speed is what? 88 kilometers per hour. So it's just like a rate. The more speed that you have, or the faster you move, it means you arrive earlier. So let's see the condition of these two, is because it was not exactly on that. But the question here is that how long, meaning to say, calculate or determine the time the young couple drive before their uncle caught. Before he caught up with them. If he had traveled for 5 hours, for that condition, the time frame for the uncle is 5 hours. That is what we're given there. Okay. So the condition is, guys, we are moving at different speeds. You are moving at a certain speed towards a certain place. I do the same towards the certain place. There's a time that we are going to meet because one of us started to move, the other one later followed. So that was the condition of these two, the young couple and their uncle. The young couple went first, the uncle following. So what is happening is that they are moving, or they are traveling at different speeds. So these one, they are moving. The uncle is going with a certain speed, but there will come a time where they will meet. So we are told that when he had traveled for 5 hours, these ones had traveled for how long? We can only estimate that or use the distance between the 2 points. That is the only thing that we can measure to say, since they are moving with the different speeds, but what about the distance they traveled? Because the distance there must be the same in terms of where we are going to reach. The distance traveled. Because, guys, we are meeting at the same, we are starting from point A to point B. The distance from point A to point B is not changing, guys. From point A to point B, if it is 100 kilometers, it is 100 kilometers. Whether you are traveling at 80 kilometers per hour, at 120 kilometers per hour, that does not change the distance between 2 points. It will only affect the time frame and your speed to reach that particular distance. It is the time and the speed that are affected. The more speed, lesser time. Lesser speed, more time. But the distance is fixed. So that is what I want you to understand. So if you understand that, guys, it can be easier to know what you are dealing with. Since distance traveled is the same, distance traveled is the same. So if the distance traveled is the same, we are going to calculate the distance that was traveled by the young couple in terms of t, because we do not have the time for these two. So we must find the distance in terms of t, but we know the time for the uncle, so we must calculate his distance also. And that distance that he traveled in 5 hours is the one that we are going to use to equate between the two, to say the uncle moved or was traveling, or he traveled this as a numerical value. How do we find the distance? That is the question now. Remember from our DST concept, this is our distance. So it's speed times what? Speed times time. So let's go to the young couple. So to the young couple, the distance, since it is speed times time, the speed is 80. What about the time? We do not know. So it was going to be 80t kilometers. Remember, distance in kilometers. Then for the uncle, so this is for the young couple, this one. Then we go to the uncle. The uncle moving at 88 kilometers per hour and traveled for 5 hours. What was the distance at the end? Speed times time does not change. The speed, 88 kilometers per hour, time in hours. So that was going to give us 440 kilometers. So there we have got the exact value, the numerical value. Here we have the distance, but in terms of t for the young couple. So it's going to help us now to find the value of t, which is the time, by forming the equation, because we are saying the distance traveled is the same. So therefore, the distance traveled by the young couple, 80t, must be equal to the distance traveled by the uncle, which is 440. We have formed an equation, guys. As we had from our grade 8, we're working with equations. How do we solve this equation for t? All right, let me just remove this. How do we solve for t? It's a product that we have here, 80 times t. So how do we remove that? We divide. Divide by 80, divide by 80 both sides. So that was going to give us the time that was taken. And that was going to give us 5,5. Guys, this is, guys, you're asked, you're given opportunity to use calculators. Use your calculators, all right? Use your calculators, 5,5. So this is 5,5 hours in terms of our time. Our time is in hours. Remember, speed was in kilometers per hour. So therefore, the young couple took 5,5 hours, but the uncle took only 5 hours. All right. So that was the difference in terms of their speed. It is because of this, their speed. If they were moving at the same speed, it means they were going to definitely take the same time. But the speeds were different. So automatically, the time will be different. That was the condition. All right. Anyways, looking into this other part, we are given Samuel borrowed a certain amount of money. We are not told about that, but here they are saying, how much did he initially borrow? So meaning to say, according to our information, the principal is not there. That is the amount borrowed. But at this rate, at a rate of 11.5% per annum, compounded annually, we are dealing with what? Compound interest. Remember that. Over a period of 6 years, n being 6, the total amount that he paid at the end of 6 years was the accumulated amount was 670,000. That is the amount he's paying back. So the question is, what is it that he borrowed before? How much did he borrow? And do not just give us that answer, but make sure that answer is rounded off to the nearest 10. It's no longer about the question paper was saying to 2 decimal place. This, no. Unless stated otherwise, that's where it plays a role. Yes, you are dealing with money where you know that you're supposed to work with 2 decimal places, but that part is no longer applicable. So how do you answer this, guys? All right. This is a compound interest. I talked about this in term 1. Remember that compound interest, I said A, the accumulated amount is equal to the principal into 1 plus R over 100, like this, to the exponent of n. So we do understand that we can calculate whatever that we want, provided that the information is properly given. So here it was to calculate the principal here, which is P. If you had substituted your values, let's see, our A, 670,000 is equal to P into 1 plus, what is our R there? The interest rate, 11.5 as it is, 11.5 over 100. Remember, the over 100 is to remove what? The percentage. It is to remove that percentage that we are seeing to the exponent of 6. So we want to calculate a P, and this is a product. So you can simply divide by this bracket as it is, or you can simplify what is inside of the bracket, 1 plus 11.5 over what? Over 100, like this. You can even simplify that. So it was going to give us 1.12. So it follows that 670,000 is equal to P into the bracket of 1.12 to the exponent of 6. A product, a multiplication like before. How do we solve? To find P is to solve for P. In an equation, guys, remove this. How do you remove this? It is going to be divided because we are multiplying. So you simply divide by 1.16 to the exponent of 6. I mean 1.12. 1.12 to the exponent of 6. So that these can cancel and you remain with what? You remain with P, which is our principal, the money that was borrowed. So 670,000 into 1.12 to the exponent of 6. So this is what we are going to have, 3, 3, 9. Then we round off to that decimal that we are given. It's 442.85. So remember they said to round off to the nearest 10. To the nearest 10 is just like from the units you're going to left this side. So remember that it's units, it's tens, it's 100, thousands, 10,000, so on. So to the nearest 10, we look where 10 is here. The number that is following that is a 2. So is this 2 going to affect that 4 or not? This one. Is it going to affect? Is it going to be affected by a 2? That is the question. Is it going to be affected by a 2? All right. I wanted to check. Let's see this value again. This is 3. All right. 670,000. All right. All right. Let me do this and see. I want us to see something again before we round off here. This was the same presentation. Remember, if you could have divided by the bracket, this is what you're supposed to get. It means inside this bracket, there's something That is wrong here. 11,5 over 100 like this. Oh, it's because, all right, guys, I am the one who is forgetting that my calculator is fixed here. Let's see if we go back to the normal, what was supposed to be the exact value here. Because I don't want to use these rounded off values. So it was supposed to be 115 like this. So let's use the exact value here. So if you're using a rounded figure, guys, this is what you're going to do. Well, some of you could have used this one. Let me just do for you. You're going to get this as 339. The 2 is not going to change here, so it'll be 40 like this. Okay, this is what you're going to get, because here your calculator is fixed. So it is now it's something that is difficult for even you to realize that this is the exact value, because the calculator is just giving you the answer. It is fixed to 2 decimal places. I see that. So to avoid that, or to have that in another way, in this case, we're going to take it here using exact values, not to say this is rounded or not. From this stage here, from this decimal that we had. So we're going to take this stage, we go with it this side. All right, so it was going to be like this. It was going to be 670,000 is equal to P into this value under the bracket without being rounded off. It's 1,115, as you can see it here. All right. So that was going to be 1,115 to the exponent of 6. Then we do the same thing, just like the previous case. We divide by 1,115 to the exponent of 6 to the exponent of 6 like this. So this was definitely going to cancel. So therefore, our principal was going to be this over that, which is 670,000. This is the whole value that we have divided to that. So it is just like that, guys. 670,000 over what? That is 1,115 to the exponent of 6. So as you can see, our answers, they are a little bit different. A little bit different. So it was going to be 348, 678,84. Totally different. So I will advise you guys to use exact values, especially if you're dealing with finance, especially when it's like that. Just make sure you put your calculator to the normal mode, all right? So that you don't have that mistake happening. But in terms of exam, they'll mark this one. It is actually fine because that is what your calculator was showing you. So at the end of the day, the principal here, if we're having to the nearest 10, remember this is our units, our tens, and so on. So 8 is greater than 5. It can change this 7 into 8. So it was going to be 3, 4, 8, 6. Remember the 7 is now 8. So it is 8, 0. The 8 that we are having at the end, that is representing the units, this one, okay, will be replaced by our what? A 0. So that is how we round off to the nearest 10. If you are given any condition that you are working with, make sure that you do understand question. Make sure you do understand the question. And the instruction thereafter, your answers rounded off to what? So some of us, we just answer the questions. We don't follow to say the instruction thereafter. What is it about that? We just consider, all right, as long as I have used the information that is on the question is fine. No, guys, let us understand the question. Questions, they come in a different way. They might be in the same presentation, but differently asked or the way that they want you to answer that question is different from a previous one. So that's why I advise you to do a lot of question papers as an individual so that you can relate these questions together. So moving on to question number 3, where we are given the first part 3.1, that is choose the word within the brackets to complete the sentence. The quotient of two numbers with the different signs is always what? Guys, we understand as we are dealing with a certain number, product, addition, but as long the different signs meet at the end, a negative will be the one that will lead in that concept. So meaning to say, whether we started with a positive, whether we started with a negative, we end up with a negative on the coefficient. So that is what the question was about. If the two numbers are having different, like the quotient of two numbers with different signs, will always be what? So in terms of simplification, combination of signs, it's a combination of signs, the way that the question is about. Do not take it in a way that you are adding -3 to 5, then it changes to a positive. No, this one is on combination of signs. When two different signs at the end of the day, it's going to be what? A negative. So fill in with less than, greater than, or equal to. With this information that we are given, this is -2, like this. So the negative is outside of the bracket. The 2 is raised, yes, to the exponent of 2 to give us a 4, 2 times 2. But what about the negative? The negative is outside of the bracket, will also affect our answer at the end. So answer will carry a negative. So it means this is simply a -4. So -4 and -4, they're equal, guys. All right. Simplify. What are we asked to simplify? -1 raised to the exponent of 2022, like this, plus a -1 in brackets raised to the exponent of 2024, like this. What are we going to have at the end? So looking into this question, guys, we do understand that 1 raised to any exponent, it will remain as a 1. So here the negative is not on 1. The negative is on its own. So what is raised to the exponent of 2022 in this case is the 1, this one. The 1, this, is it like this? So there are two separate things here. So it means our answer, we're going to start by the minus because it's not affected by the exponent. So it's minus. Then when 1 is raised to any exponent, it remains as a 1. So at the end, we're going to have -1. We move on. There's a sign there, a plus. What are we going to add? A -1 in brackets, when it is like this, it means even the negative is also affected by the exponent. Even the negative sign. So we go back to that concept when a negative is raised to an even exponent, it changes to be a positive. So once we have this negative raised to an even, it is now a positive that we have. But remember what I said, guys. 1, when raised to any exponent, it remains as a 1. So it was going to be -1 plus +1. But remember, guys, this plus is no longer effective. Plus and plus gives us a plus. So it's -1 plus 1, which is what? Which is a 0 at the end. So that was to simplify our question. We just needed to reinvestigate what is happening in terms of the given numbers. Calculate for this part, calculate the following without using a calculator. Leave answers in the simplest form. All right, so this is straightforward. We just look into the numbers. 2 minus 4 to the exponent of 3, guys. Even if they say do not use a calculator, guys, if you do not know, just use a calculator on this one. On separate terms, they are saying don't use a calculator at once to say you just evaluate everything. But to simplify numbers such as 4 to the exponent of 3, guys, you can even use a calculator. It's not even a problem. So 4 to the exponent of 3 is 64. Then there's a plus and a minus. Plus and minus, we know that it's going to give us a negative. So that's negative 12 plus the square root of 12 of 144, sorry, which is 12. So as we can see, guys, these two are the same. So they will just eliminate each other. Minus 12 plus 12, that's a 0 there. So meaning to say we got a 0 here. So it's 2 minus 64, which is what? Minus 62. These are now directed numbers. But like I said, even if you do not know, who is going to know that you have used a calculator to subtract 2 minus 64? No one. Use a calculator, guys. They are just saying, do not use a calculator. Straightforward. 2 minus 4 to the exponent of 3. Like this, because we can do it. Plus a minus 12 like this. Then whatever that we have, we've got the square root of 144. We could have done that. They are saying don't use your calculator straightforward like this, but you can use it to simplify stage by stage. It's not even a problem. So even if I do not understand some of these guys, I can use the calculator. It's not even a problem at all. All right, simplifying this, minus raised to the exponent of 3. This is minus square root of 25 to the exponent of 3. So we start with a negative. Remember, I talked about this, a negative. Now it's raised to an odd number. It remains as a negative. So it was going to remain as a negative. What is the square root of 25? It is 5. All right. To the exponent of 3. Okay, let's ignore that and just write to the exponent of 3. Then we're going to consider the exponents later on. The cube root of minus 8 on the other hand to the exponent of 2. What is the cube root of minus 8? That's minus 2 to the exponent of 2. The number that multiplies itself 3 times minus 2 times minus 2 times minus 2. It gives us what? Minus 8. Or you can use your calculator. Then minus 3 times minus 3 squared. So it's minus 3 squared like this. So it's minus 3 times minus squared. That's a positive. Remember, a negative raised to an even, it gives us a positive. So 2 is an even number. It's a positive. 3 raised to the exponent of 2 is 9. So it was going to be 3 times 9. Sorry, minus 3 times 9. Plus 2 times 2 here is a 4. Plus there's a 3 at the end. So this is what you're going to actually have at the end. And we can simplify further. Minus 3, minus 5 raised to the exponent of 3. We are now back to that. A negative raised to an odd remains as a negative. So it was going to remain as a negative. But what is 5 to the exponent of 3? If you multiply 5 times 5 times 5, 3 times, it was going to give us 125. Times a negative 2 squared. A negative to an even number gives us a positive. So the answer was going to be positive 2 squared, which is 4. Everything over what is in the denominator, where we can simplify negative 3 times 9, that's negative 27, plus 4 plus 3, which is what? Which is 7. Guys, we can even use our calculator here. You can multiply 125 times 4, negative 125 times 4, which was going to be negative 500, over minus 27 plus a 7, that's a minus 20. So guys, as you can see where we are, mathematically, we can cancel this. We are allowed, we can cancel this and this. 2 into 50, that's a 25. So meaning to say, at the end, our answer was going to be what? A 25. So this is it. So you can even use the calculator at once to verify your answers. You're not supposed to get wrong answers because verification is there. Match column A with correct answer in column B. So this is what we have, guys. The column A are the questions, then B are the answers. So that is what we want here. So 4.11, which is this part. If we were to simplify, we're going to multiply 3 times 3. We get a 9. But this is not what we have. We don't have a 9. What happened? We know that 3 times 3, which is same as 9, is same as 3 squared. So do not panic. It is same as 3 squared. What about p times p? That is p squared. So do we have 9p squared or 3 squared p squared? We have that. 3 squared p squared is there on C, this part. So 4.11 was going to be C. The correct answer there was going to be from C. You take the answers the way they are presented. You don't say, okay, my answer is supposed to be 9p squared. It's not there. Then you say, okay, no answer, no. Figure out. 4.12, if we were to multiply 3 over p times 3 over p, according to our multiplication, we know that we are going to multiply the numerators together. 3 times 3, which is 9. P times p, which is p squared. We don't have a 9 here. And also, we do not have fractions. So the only thing to avoid fractions was to take the p squared on top. How do we write 1 over a to the exponent of n on top? It is a to the exponent of minus n. It carries a negative. So that it was going to give us 9p to the exponent of minus 2. A positive exponent to be written in the numerator as it is like this. It carries a negative. But we don't have this. What about the 9? Remember, 9 is same as 3 squared. So in place of that 9, it can be written as 3 squared p to the exponent of minus 2. Do we have that? 3 squared p to the exponent of minus 2. That's our a here. So that was going to be here. So you answer according to the answers that you are given there. All right. Anyways, let's see the other part, 4.13, same as what I just applied on this one, because the multiplication, you're going to multiply the numerators together, 1 times, all this. It was going to give us a 1 over what? You multiply this to this, to this, to this. What does it mean? Let's just say 2 times 2 times 2 times 2. It means 2 to the exponent of 4. It is multiplying itself 4 times. The p to the exponent of minus 2 in the same manner. It is multiplying itself 4 times. These in the denominators. So what does it mean? It simply means it is p to the exponent of minus 2 being raised to the exponent of 4. Just like 2 times 2 times 2 times 2. It gives us 2 to the exponent of 4. So whatever that multiplies itself to a certain number, that will be its exponent. So it was supposed to be 1 over p to the exponent of minus 2 like this, raised to the exponent of f4. That is how our answer was supposed to be. But remember, we don't have fractions here. So we rewrite it to be a proper term, which is not a fraction. So how is that possible? Remember, we said anything that carries a positive will carry a negative. So what if it is already carrying a negative like this? It is already carrying a negative. It will carry a positive, vice versa. Once there is a 1 over, the sign changes, which is on the exponent. So it means this sign on the exponent, the minus, will change to a positive 2. But everything raised to the exponent of 4 like this. That is the case here. It's a law. Exponents is all about laws. So it can be written like this with a positive exponent. Do we have a proper answer for that? Yes, we have, which is on D. So it means 4.13, the answer was supposed to be D. That's how these questions can be given as. Understand your question. Understand question. 4.2, prove the following that PQ is same as Q over P to the exponent of -1. So PQ cannot be simplified, but on this side, we can simplify because we know that a -1 is same as 1 over P. It's a law that we know from our laws of exponents. It's same as what? 1 over P. So if it is same as 1 over P, therefore it means there are two different terms to be considered. Q, which is on its own, divided to the 1 over P, which is on its own, this one. That is how it means. That is what it simply means. So you divide to 1 over P. Let us simplify and see. Q is same as Q over 1, as we do understand. So Q over 1, how do we get rid of a division? We introduce a multiplication, but remember, we have to interchange or to invert the second one. So P is B will be on top, 1 in the denominator. So you multiply the numerators together. It was going to give us what? PQ or QP. QP, remember, is same as what? PQ. So this was going to give us PQ over 1, which is same as PQ. So as we can see, this is the same PQ that they want us to have at the end. That is to prove that what you see on the left-hand side is the same as what you see on your right-hand side. So you simplify one side. So in our case, we simplified the right-hand side and we ended up with a PQ, which is the same as what we have on our left-hand side. So it means we have managed to prove our question, to prove that statement. Simplify on 4.31, we are given a condition to simplify just like other questions. So let's start the numerator. We have got multiplication. Remember, if the bases are the same and you're multiplying, you add exponents. So there is r to the exponent of -2. There's r to the exponent of 4. So it was going to be r to the exponent of -2 plus 4, which is r squared. -2 plus 2 is 2. So that's r squared. Then the same on s. There is s to the exponent of -5 and also s to the exponent of -2. So you add -5 plus -2. So that's s to the exponent of -5 minus 2, which is s to the exponent of -7. So there we're going to have s to the exponent of -7, everything over the denominator, which is already in simplest form, r squared, s to the exponent of 6. Okay? The r squared and r squared, these two can simply cancel, guys. Yes, we can use laws of exponents. We subtract the exponents, then we've got r to the exponent of 0, which is same as 1. But guys, let's cancel. They're the same. 2 over 2 can cancel and get us 1 and give us a 1. All right? Division of exponents, same basis, subtract the exponents. So it was going to be s to the exponent of -7 minus 6. We subtract. So that is going to give us s to the exponent of -7 minus 6, which is -13. You can leave your answer like this, or you can get rid of the negative, which is 1 over s to the exponent of 13. Remember, I talked about this removal of a negative exponent. It's all about the laws. So go through the introductions. I talked about these so that you do not mistaken what we are doing in these revisions. These are just revisions, guys. Go through the introductions where you do not understand much. 5p to the exponent of 0 times p, all right? Remember, any number to the exponent of a 0 is what? Is 1. So it is just like 5 times 1 times p plus every number to the exponent of 0. So it's just like 1 times p. That is what it means. Everything over minus 2 to the exponent of 2, which is a 4, p to the exponent of 2, which is p squared. But remember, the negative will affect the answer at the end. So meaning to say 5 times 1, guys, that is just 5. So that's 5p. 1 times p, guys, that's p, or just 1p like this. Everything over minus 4p squared. You multiply, guys. This is just a single term, so it will be minus 4. So in the numerator, we can add, because these are like terms, 5p and 1p. Same exponent, same term. So let's add 5 plus 1, the coefficients of p. So that's 6p, everything over minus 4p squared. Using the laws of exponents, yes, it's fine. Or you can even just reduce these numbers by 2. 6 divided by 2, that's a 3. 4 divided by 2, that's a 2. But we can even see, guys, there's a p here. Here it's 1, cancel it. How many p's do we have here? There are 2, so we remain with 1 p in the denominator. And we do understand that the negative goes to the numerator on top. So it will be minus 3 over what? There is a 2 that we have and a p in the denominator. The minus goes to the numerator, just like that. You have simplified. You have simplified. On question number 5, we are given Tn. From that Tn, it represents the nth term, our Tn, which is given as 4n plus 3. Determine the first 2 terms of the sequence. The first 2 terms. If the first term of the order 1, 2, 3, we can consider that as T1. So T1 from Tn, it means n is represented by 1. So what does it mean? Wherever we see n on the other side, we must substitute a 1. So that's T1. So it means 4 into 1 plus a 3. So what is going to be our T1 at the end? 4 times 1, that's 4, plus 3, which is 7. So the first term is 7. The second term, using the same situation, n is now 2. So in place of n, we put a 2. So that's 4. Where n is here, substitute, put a 2 there, plus 3. All right, so that's our T2, our second term, 4 times 3, which is 8. Then 8 plus 3 is 11. So it means our terms will be 7, 11. These are the first 2 terms that we are given. All right, just like that, guys, we are done. Which term is equal to 867? 867 is a term, just like Tn. So if our Tn was equal to 4n plus 3, now the same Tn is given numerically as 867. That is our numerical value. So the question is, from this numerical value that we have, so this simply means that we now have an equation, because we are saying these two, they are the same. So if these two are simply the same, 4n plus 3 must be equal to 867. And from there, we can solve for n, which is now, they tend to say, which term that is corresponding there. So as an equation, how are you going to solve for n? We can take the plus 3 to the other side of the equation. It was a plus. The moment it crosses the equal sign, we know that it will be a negative. So that's 867 minus 3. So that's 4n is equal to 864. If we subtract this, you get 864. So to find n, that's a product as we can see here. So we can simply divide by 4. Divide by 4. Divide by 4 both sides of our equation. So that was going to give us 216. 864 divided by, that is divided by 4 like this, which is 216. So that's our n, the number that is corresponding the nth term, which means 216 term is going to be corresponding to that part. 5.2, we are given winter is when most flu viruses spread and multiply quickly. The way in which the virus multiplies can be represented by the following sketch. 0 minutes, 1 minute, 2 minutes, 3 minutes, and so on and so on, which is later presented. We can see that the 0 is 1 like this, to say the only thing that we have, the number of virus is 1. Under 1 minute, this is what we see under 1 minute. So we've got 1, 2. So this is what we are given on this table. 0 minute, that is 1. Under 1 minute, there are 2. Under 2 minutes, how many do we see under 2 minutes? 1, 2, 3, 4, which is this part. The same thing under 3 minutes, and so on and so on. So the question is, complete the table below to show how the virus multiplies. How is this going, guys? We started with the 1. Now there are 2. From 2, there are 4. From 4, there are 8. What is happening? It simply means from here to the next level from the previous one to go to the next, they are multiplying by 2. It was 1, now they are 2. These ones, remember, they are 2. Let's multiply them by 2 and see. If we multiply them by 2, you get a 4. These viruses that we see, they are 4. Multiply them by 2, we'll get 8. So it simply means we are multiplying by 2, by 2, by 2, like that. So to get the next one, it was going to be like that. 8 viruses times 2. So that is what is happening here. To get this next number, times 2, times 2, times 2, and so on. So 8 times 2 is going to give us what? A 16. We do the same thing times a 2. 16 times 2, which is a 32. Just like that. Or if we consider this, we can see that it is just taking the 2 and raise it to the exponent to the number of minutes, 0, 1, 2, and so on. We know that 2 to the exponent of 0 is what? That's a 1. 2 to the exponent of a 1, which is a 2. The same thing, 2 to the exponent of a 2, which is what? Which is a 4 that we see here. 2 to the exponent of a 3 gives us an 8. Same thing. So meaning to say this one, 2 to the exponent of 4 was going to give us a 16. This one, 2 to the exponent of 5, a 32. That's another way that we could have used if you understand that. So there are 2 ways in this case. Not only one, but 2 ways. So describe the pattern above in words. So depending with the way that you used, but if you're using mine, we are simply multiplying by 2 here to get the next term. So from the previous term, multiply by 2. But we started with what? We started with a 1. So simply start with 1, then multiply by 2. All right, start with 1 and multiply by 2. All right, and multiply by 2 the previous terms. And multiply by 2 the previous term, just like that. So to get the next term, you multiply by 2. That is what we saw or you can describe the other one that I was explaining, raising to the exponent of 2 like that. Question number 6, given this part, 6.11, how many terms are there in the expression above in this expression? You can see this is a term on its own, plus, that's another term, plus, that's another term, minus, that's another term. 1, 2, 3, 4. So we're talking of 4 terms in that case. All right, so our main terms, there are 4 of them. And from these terms, what is the coefficient of x? Where we see x, what is it that is affecting x? If it is like this, the coefficient of x is 5. Do we have any part where x is not x to the exponent of 3, not x to the x as it is to the exponent of 1? So if we check properly, we're going to see that x is here. This is where we have got x here. So where we see x, everything surrounding that x becomes the coefficient. Whether it is a letter or what, it becomes the coefficient. So the coefficient of x was going to be plus 75y. Even if y is a letter, at that point, it becomes useless. So it's just 75y. All right, the plus is not a big deal. But if there was a negative, you were not going to ignore the negative. All right. So that was it here on the coefficient of x. We move on to 6.13. What is the highest degree of the expression in x? All right, the expression or term in x. All right, where we see x, which one has got the highest power? The highest power is in 4. This is 3. So the highest power is 4. So meaning to say we talk of the 4th degree. In terms of the power, we call it the degree. So that's the 4th degree. All right, 6.2, we are now given this. Determine the value of the expression by substituting a is -1 and b is 2. If, that is what it means there. If a is -1, if b is 2, substitute them into the given expression as it is in place of a, in place of b. All right, so this is minus a minus, what is our a? Our a is -1. Minus times minus. Plus, that's a bracket, 2b. So in this case, 2b. 2b means 2 times. What is our b? Our b is 2. So 2 times 2 is what? That's a 4. So it was going to give us 4 minus 2a minus 2 times a, which is -1. Minus 2 times -1, minus, when we multiply, minus and minus, that's a positive. So it was going to give us a positive 2. That is what we have. So the whole bracket is raised to the exponent of 3. So we managed to simplify some stages, some. Minus and a minus, remember that's a plus, so that's +1. +1 is just same as 1. Plus 4 plus 2, which is what? 6, raised to the exponent of 3. So that's 1 plus 6 times 6 times 6, 3 times. 3 times. So it was going to give us 216, and we add, we got 217. We can even use our calculator, guys, on the rest. Do not panic, do not worry. The calculator is there. Simplify this part on 6.31. Given the brackets, here we can expand -3 times a, distribute here. All right, but take note, there is another bracket also. There are 2 of them. So let's start with these 2. -3a into this one, a times 2a, that's 2a squared, a times minus b squared, that's minus ab squared, like this. Okay, a is going to multiply this. We are done with this part. Then we move on to plus b. We multiply by it, plus b multiplies a. So it was going to be 2ab or 2ba. 2ba, 2ab, one and the same thing. So do not panic again. So this was going to be plus 2ab. Since we started with a here and ended with b, let's do the same thing. So 2ab, 2ba, one and the same. Then we do the same, b times minus b squared. So that will be minus b to the exponent of 3. We add the exponents. We are multiplying. Same basis, so add the exponents. 1 plus 2, which was going to give us a 3. Do we have any like terms inside of the bracket? We do not have any. So just expand again by minus 3a. We distribute. So that's minus 3a. It's going to multiply here. Minus 3 and 2 is going to be minus 6a to the exponent of 3. Remember, this is 1 plus 2, which is 3. Minus and the minus here, that will be positive 3. Then a times a is what? Is a squared. Then the b is not affected, so it will be just b squared. So we are done with this part. We multiply this to this one. All right, we move on. Minus 3a, it multiplies also the 2ab. So let's start with the sign. Minus and a plus. That's a minus. 3 times 2, which is 6. A times a, which is a squared. Then b remains as it is. We move on to the last term. Minus 3a multiplies what is on the end there. So it's minus 2 and minus. Minus and minus, that's a plus. So it's 3. A, b to the exponent of 3. As we can see, these are unlike terms, or the terms that actually even the laws of exponents can be used. You just take your a as it is, b as it is. Nothing combines the way that it is presented or given there. So if we check, do we have any part that we can call, okay, these are like terms? We do not have. Guys, do not force the questions to be what they cannot be. What they cannot be like this. If it is like this, where you do not have any like terms, leave it like that. You are done. All right, 6.32, 2 to the exponent of 3, that is going to give us 8. X to the exponent of 2 to the exponent of 3. Remember, you multiply, so that was going to be x to the exponent of 6 plus the cube root of 8. This is 27. The cube root of 27, which is 3, and the cube root of x to the exponent of 12 simply means divide by the cube root, divide by the number inside of the root. So 12 divided by 3 is going to give us a 4. If you've got any other way of simplifying, guys, it's fine. You still get the same answer. Minus 8 to the exponent of 4x to the exponent of 4. This one is not affected here, but it is a like term at the end. These are like terms. X to the exponent of 4, x to the exponent of 4, same power. So we can simplify these two at the end. So we just consider the coefficients of x. There is a 3 plus 3, and this is minus 8. So 3 minus 8 is what? Minus 5. 3 minus 8, that is minus 5. Just like that. So this is what you're going to have at the end. This cannot be simplified. They are unlike terms, so you can leave your answer as it is. Factorize. What do we have? A difference of 2 squares, p squared minus 25. This is same as p squared minus 5 squared, guys. Remember, that's a difference of 2 squares. So you understand, one bracket will subtract, another one will add. So that's the p and the 5. The p and the 5. Just like that. 6x to the exponent, 6.42, we are given 3x to the exponent of 2 minus 21x plus 30. Again, to factorize, the golden rule, factor out highest common factor. That's the first thing. Do we have between these three terms, 1, 2, 3, the highest common factor? Do we have it? What is that highest common factor? That's a 3. 3, 21, 30. X is not common, but 3 is common. So you can factor out 3. Then we divide, remember 3x squared divided by 3. This will cancel, you remain with what? X squared. Minus 21x divided by 3, guys. Minus 21 and 3 will give us a minus 7. Then 30 and 3, 30 as it is divided by 3. That was going to give us a positive 10. Yes, it's very true that we did factor out the highest common factor, which is 3. But that does mean this part here is the simplest, is being simplified. Does that mean we are done? No. Remember, we have a trinomial, 3 terms, where the highest exponent is 2. We can factorize this further by having 2 brackets. Remember the concept? For us to get x squared, it means we're having x and another x here. So how do we get the numbers that are remaining here? We said we focus on the constant, which is 10. Do we have factors of positive 10 or product, 2 of them? But these 2 factors or 2 products must add up to the middle term, meaning to say they must give us a minus 7. Do we have such? You multiply 2 numbers, you get a 10. But when you add those 2 numbers, you get a minus 7. How is that possible? We think of a 5 and a 2. It's very true that if we multiply this, we get a 10. But if we add now 5 plus 2, we get what? A 7. Not a minus 7. So what can give us a minus 7? Let's put a minus on these numbers. Minus 5, minus 2. If we multiply negative to a negative, we'll still get a positive 10 as before. Let's add now. Minus 5 plus. What are we going to add? A minus 2. We get what? A minus 7. This gives us a minus 7 if we add. So these are the numbers that we want. Minus 5 and what? Minus 5, minus 2. So that is what we're going to have in the brackets at the end. It is fully or it is completely factorized. Whatever that we are having is now fully factorized by seeing those 2 brackets. All right, question number 7, write the following statement algebraically. The sum of 3 numbers is 123. Okay? The second number is 5 times the first number. Guys, there are 3 numbers. We don't even know them. So can we call them X, Y, Z? No problem. If the first, let's say, let the first number be X. Let the first number be X. So if our first number is X, what are they saying? They're saying the second one, the second number is 5 times the first. So it means our second number will be 5 times the first. 5 times X. It means it will be 5X. That's the second one. And the third number is 2 more than. 2 more than. It is the third number that we are talking about. But it is 2 more than. More, add that. More than what? the second number. So it means when we see the second number, which is 5x, to get the third number, we must add two more. Add 5 times, 3 times, 2 times, 7 times. We multiply. 2 more, add. Less, we subtract. That's how you answer these word problems. So let's save it now as a statement because they said these numbers, 3 of them combined together, they are supposed to add up to 123. Their sum, the sum is 123, the sum of 3 numbers. So if I add the first number, which is x, plus the second number, which is 5x, plus the third one, which is 5x plus 2, our third number, if we add this, we must get the sum of what? 123. So that is it. We are done. Just write a statement like this. You are done. Don't solve anything. The question is, write the following statement algebraically. Write it algebraically. In terms of what? In terms of a certain letter. So in our case, we wrote in terms of what? In terms of x. All right, so that was it on this question. Just a single mark for that one. Then we move on to another part. To solve for the unknown in the equations below. Solve for what? For a. So how can we solve this? Just let's expand brackets. This is for a. Remember, minus 3. A has to multiply everything in this bracket. So it's minus 3 times a minus 3a times a, which is minus 3a squared. Minus 3a times minus 2, minus, that's a plus. So it was going to give us plus 6a. All right, this is an equation, guys, so I'm not supposed to put an equal here. All right, so we expand. We have expanded everything. Then we move on to this one. Plus 3a squared as it is equal to what? Is equal to 10. But as you can see, guys, those like terms and same terms, just that they're different sign. Minus 3 plus a 3, it will give us a 0. So we have totally eliminated a squared. We go to the a. 4a plus 6a, that is 10. So it's going to give us 10a. These are like terms also. So if 10a is equal to 10, what about a? Remember, a product, we divide to obtain the value of the letter that we are looking for, which is a. So therefore, a is equal to 10 divided by 10, which is 1. So that was the condition of our question. Just have to be very careful how these questions are presented. Very, very careful. Right, another one, we can simply cross multiply. These are two fractions, guys. One on the left, another one on the right. Cross multiply 3 multiplies everything on the left. So it's 3 into 2x minus 3 equal to the 2 multiplies the 5x. It's an equation. So we can solve this. Distribute by 3 each and every term. So that is 3 times 2, which is 6x. 3 times minus 3, which is negative 9, is equal to 2 times 5, which is 10x. So collecting the like terms, guys, we can even bring the minus here, whatever that you want, or you can leave it that side as minus 9. Then we take the 6x to the other side of the equation. The moment it crosses the equal sign, it changes the sign. So that's 10x minus 6x. Minus 9 is equal to 4x. 10 minus 6, that's 4. So to find x, simply divide by what? By 4 both sides. So therefore, x was going to give us negative 9 over 4. So as it is like this, you can leave your answer. It's not a problem. Going to the laws of exponents, but under equations, 3 to the exponent of x minus 2 is equal to 81 on question 7.23. What will be the value of x? 81, can it be written in the base of 3? Yes, it's very possible. 3 to the exponent of x minus 2 is same as 3 to the exponent of 4 in place of 81. Remember, you can also use your calculator to prove that. That's shift. You go to this shift fact. It's shift fact like this. Okay, you start by the number first. 81 is equal to, all right? Then you say shift fact. It will give you 3 to the exponent of a 4. So that's it. If the bases are the same, we can even neglect them because they're the same. So we equate the exponents. So therefore, x minus 2 must be equal to 4. It's an equation which is a linear equation. We are no longer about exponents here. We are back to normal equations, a linear equation. So to find the value of x, we can take the minus 2 to the other side. The moment it crosses or jumps the equal sign, it changes the sign. So therefore, we're going to have 4 plus 2, which is what? Which is 6. So the x that we're going to have at the end of the day was going to be a 6. So this is how these questions might be given as an individual. Try to go through as many question papers as you can because they do repeat. All right, on 7.3, we are given a condition here where Ryan buys twice as many 5-liter bottles of dishwashing liquid than fabric softener. So these two guys, they are same like the 5-liter. They are all 5-liter bottles, but different to say this one is a dishwashing liquid and another one is a fabric what? Softener. But the case that we are dealing with is that he bought twice as many. We meaning to say where a comparison is, we use one letter when there is a comparison. So since we are comparing the fabric softener, let that be X. Let the fabric softener that was being bought, the 5-liter ones that were being bought, be what? Be X. So if this is X, what about the dishwashing liquid? The dishwashing liquid is saying he bought twice. Twice. That is where the twice is playing a role on the dishwashing liquid. It is what? It is twice of these fabric softener. So if it is twice, if the fabric softener is represented by X, it means dishwashing will be represented by what? By 2X automatically. They are two different, but because of we are comparing them, we cannot use different letters. But in actual sense, we're supposed to say, let this one be X, let another one be Y. But we cannot do that because they compared. The problem is they made a comparison. If it was not the case, it was not going to be like that. So anyways, the question is, we now know these are the 5-liter bottles of what? Softener. They are represented by X, but the dishwashing, the 5-liter of them will be represented by 2X. It's just twice to say, if we bought one fabric softener, dishwashing liquid will be 2. If these ones are 3, we multiply by 2. It means this one they are 6. If these ones are 5, 5 times 2, these ones they are 10. That is the case. We are multiplying by 2. So in our case, they are saying now, he paid 120 per 5-liter bottle of fabric softener, which is the X. 150 per 5-liter bottle of the dishwashing, but the total is this 2,520. How many 5-liter bottles of dishwashing liquid did he buy? Dishwashing liquid, the 5 liters of them are represented by 2X. So simply solve for what? For X. After solving for X, we can find 2X. How? That is the question. You must put this into an equation now. He paid 120 rand for what? Per 5-liter bottle each. How many do we have for fabric softener? We don't know, but they are represented with what? With X. So it means 120X plus 150 is being paid per what? 5-liter bottle dishwashing. Do we know how many are they? No. In terms of X, there are 2X. So we are going to multiply 150 times 2X, the dishwashing liquid that we have. All this in terms of the amount that was spent, it was going to give us 2,520 rand. All this. Meaning to say we have formed an equation that we need to solve for X. So that was going to be 120X, 150 times 2, which is 300. So that's 300X is equal to 2,520. As we can see, that's a condition of like terms. Collect the like terms, 120 and 300. Add them together. 420X is equal to this. So how do we find X? Simply divide by 420 by 420 both sides. So guys, this is you and your calculator. You can even use your calculator. 2520 like this divided by 420 was going to give us 6. So X is equal to 6. X represents what? Don't end there. X represents what? Fabric softener. We said let it be X. Is it what the question is about? No. How many 5-liter bottles of what? Dishwashing liquid. The dishwashing liquid is represented by 2X. So as we are talking about the dishwashing liquid, guys, as long we are talking about this, it must be 2X. So 2X means 2 times the X that we see here, which is 6. So 2 times 6 was going to give us 12. So therefore, we had 12 5-liter bottles of what? Dishwashing liquid. That is the case that we are having here. How many did he buy? Meaning to say, Rain, he bought 12 5-liter. These are 12 5-liter bottles of what? The dishwashing liquid. They are bottles, these ones, but 12 of them. So that is the condition. So guys, as we can see that we have a lot to discuss. We have a lot to talk about in our revisions. That is why we find giving more time than the given time for the question paper. All right. So if the question paper is saying this, I might answer that same question paper within a certain period of time just for you guys to understand what is happening. But for those who are going through the introductions, I hope you are understanding much better, because those introductions, they carry more information, the information on how to answer the questions from the understanding of its introduction, like where it is coming from, the questions that you expect in your syllabus. As you are revising, make sure that you have your ATP, as I talked about before, so that you know exactly the topics that you are dealing with in this term. Each term, know what you are working with. Don't just revise from nowhere or open a certain topic that is not part of that term. do as per term as required in your annual teaching plan. With that, you won't miss your exams. You will score better marks in your exams. So that is it, guys. Let us continue to have our revisions where we have got questions. Let us communicate so that we work on those separately. But for now, that's it. Till we meet again.